For years, people believed the future of artificial intelligence would be decided by only a handful of companies and countries. The race seemed to revolve around who could build the biggest language models, buy the most powerful chips, and construct the largest data centers. But behind that global competition, another story has quietly been taking shape. It is not about one country trying to dominate AI on its own. It is about two nations with very different strengths, discovering that, together, they may solve problems neither could solve as efficiently alone. India brings one of the world's largest digital populations, a rapidly growing software industry, and an enormous demand for AI services in dozens of languages. Japan brings decades of experience in advanced manufacturing, semiconductor technology, industrial automation, and precision engineering. As artificial intelligence becomes more important to economies than ever before, these strengths are beginning to intersect. That is why discussions between India and Japan are increasingly focused on far more than trade or diplomacy. The conversation is expanding into semiconductors, large language models, cloud infrastructure, data centers, research partnerships, and digital supply chains. Together, these pieces form what many observers now describe as an emerging AI roadmap. To understand why this partnership matters, we first need to understand why AI has become much more than software. When most people think about artificial intelligence, they imagine a chatbot answering questions or generating images. But those applications sit at the very top of a much larger system. At the bottom are semiconductor factories producing advanced chips. Above that are companies assembling servers filled with thousands of graphics processors. Those servers are placed inside massive data centers that require enormous amounts of electricity, cooling, networking equipment, and fiber optic connections. Only after all of this infrastructure is in place can engineers begin training large language models, often called LLMs. In other words, AI is not built with software alone. It depends on an entire industrial ecosystem. This is exactly where India and Japan begin to complement each other. Japan has spent decades becoming one of the world's most important players in the semiconductor industry. While headlines often focus on companies that design cutting-edge chips, manufacturing those chips requires hundreds of specialized materials, chemicals, testing systems, precision machines, and production equipment. Japanese companies have long supplied many of these essential technologies. Some produce advanced silicon wafers, others manufacture lithography components, semiconductor chemicals, testing instruments, specialty glass, and industrial robotics. Many of these products are invisible to ordinary consumers, yet modern electronics cannot be built without them. India's position has traditionally been different. Instead of dominating semiconductor manufacturing, India became known for software development, IT services, engineering talent, digital payments, and large-scale technology platforms. Over the last 20 years, the country has built one of the world's largest pools of software engineers. Its digital public infrastructure, including systems for identity verification, digital payments, and electronic documentation, has demonstrated that technology can operate successfully at population scale. Artificial intelligence increasingly requires both worlds. Powerful hardware without software has limited value. Powerful software without reliable computing infrastructure eventually reaches its limits. That is why cooperation has become increasingly attractive. Semiconductors are perhaps the clearest example. The global chip shortage during the pandemic revealed just how dependent modern economies had become on complex international supply chains. A disruption in one region affected automobile factories, consumer electronics, industrial equipment, telecommunications, and countless other industries around the world. Governments began asking an uncomfortable question: should such a critical technology depend on only a small number of manufacturing locations? Many countries responded by investing in domestic semiconductor capacity or building partnerships with trusted international partners. India was among them. The country announced incentive programs designed to attract semiconductor manufacturing and packaging facilities. While building a complete chip ecosystem takes many years, partnerships with experienced countries became an important part of the strategy. Japan naturally entered that conversation.
Japanese expertise extends far beyond producing finished chips. It includes the specialized knowledge required to support every stage of semiconductor production, from materials and manufacturing equipment to quality control and advanced engineering. This creates opportunities that go beyond simple investment. Training engineers. Sharing manufacturing knowledge. Developing supplier networks. Improving industrial standards. Each step strengthens the overall ecosystem rather than focusing on a single factory. But semiconductors are only one part of the story. The second pillar is artificial intelligence itself. Large language models require extraordinary computing power. Training one advanced model involves billions or even trillions of mathematical calculations. Those calculations are performed by thousands of GPUs working together inside high-performance data centers. Until recently, many countries depended heavily on foreign cloud providers to access the computing capacity. Now governments and businesses increasingly recognize that domestic AI infrastructure offers important advantages. Sensitive workloads can remain inside national borders. Researchers gain more predictable access to computing resources. Local startups are less dependent on international cloud availability. India has already begun expanding its domestic AI computing capabilities through initiatives designed to provide GPU resources for research and innovation. Japan, meanwhile, is also investing heavily in AI infrastructure, cloud services, and advanced computing. The interesting question is not whether each country can build these systems independently. The more important question is what happens when they connect them through research partnerships, investment, and shared technological development. This brings us to the idea of AI ecosystems rather than individual AI products. Imagine trying to build an automobile industry. Simply assembling cars is not enough. You also need steel producers, tire manufacturers, electronic suppliers, logistics companies, engineers, maintenance services, financing, research laboratories, and skilled workers. Artificial intelligence is beginning to resemble that kind of industrial network. Semiconductor production. Cloud infrastructure. Power generation. Cooling technology. Fiber optic communications. Software engineering. Cybersecurity. Machine learning research. Data management. Each depends on the others. The India-Japan relationship increasingly reflects this broader understanding. One area receiving growing attention is data centers. People often imagine data centers as ordinary office buildings filled with computers. The reality is very different. Modern AI data centers are among the most sophisticated industrial facilities in the world. Thousands of servers operate continuously. Electricity must remain stable every second. Cooling systems remove enormous amounts of heat. High-speed networking allows processors to communicate almost instantly. Even small improvements in energy efficiency can save millions of dollars over time. Building these facilities requires expertise from multiple industries. Construction. Electrical engineering. Mechanical systems. Networking. Power management. Software. This creates another opportunity for collaboration. India offers one of the world's fastest-growing digital markets. Demand for cloud computing continues to rise as businesses adopt AI, online services, and digital platforms. Japan contributes decades of engineering experience in precision systems, industrial infrastructure, and energy-efficient technologies. Together, these strengths could support more resilient digital infrastructure across the region. Another important area is multilingual AI. Many global language models perform exceptionally well in English. But Asia is home to hundreds of languages spoken by billions of people. India alone has extraordinary linguistic diversity. Building AI that understands these languages accurately requires specialized datasets, careful training, and cultural understanding. This is not simply a translation problem. Language carries history, context, local expressions, and social meaning. An AI system that understands grammar but misses cultural context often produces weaker results. India's large multilingual population creates valuable opportunities for developing more inclusive AI systems. Japanese researchers are also working on language technologies optimized for Japanese and other regional applications. Research collaboration between universities, technology companies, and government institutions could accelerate progress that benefits both countries.
Healthcare provides another example. Artificial intelligence is increasingly assisting doctors with medical imaging, disease detection, hospital administration, and drug discovery. However, these systems perform best when trained using relevant healthcare environments and carefully managed datasets. Joint research allows knowledge to move across borders while respecting privacy and regulatory requirements. The same principle applies to manufacturing. Japan remains one of the world's leaders in industrial automation. Factories increasingly use AI to predict equipment failures, improve quality control, reduce waste, and optimize production. India's expanding manufacturing sector can benefit from these technologies while adapting them to local industries. This creates a cycle of shared innovation. Japanese industrial expertise supports manufacturing modernization. Indian software talent develops customized AI applications. Research institutions improve machine learning methods. Manufacturers adopt the results. The lessons then feed back into future research. But every ambitious partnership also faces challenges. One of the largest is talent development. Artificial intelligence evolves incredibly quickly. Universities must continually update engineering programs. Companies need skilled researchers capable of designing increasingly sophisticated systems. Governments must encourage both education and innovation. India produces large numbers of engineering graduates every year. Japan possesses deep industrial experience developed over decades. Combining youthful software talent with experienced manufacturing knowledge may become one of the partnership's greatest advantages. Another challenge involves supply chain resilience. The semiconductor industry has learned that concentration creates vulnerability. Natural disasters, geopolitical tensions, transportation disruptions, unexpected demand. Any one of these can interrupt production. Diversifying manufacturing partnerships reduces some of those risks. This explains why semiconductor cooperation has become both an economic and strategic priority. Cybersecurity also becomes increasingly important. As AI systems manage financial transactions, industrial equipment, healthcare information, transportation networks, and government services, protecting digital infrastructure becomes essential. Collaboration in cybersecurity, secure hardware design, and trusted computing may prove just as valuable as cooperation in AI itself. Then there is energy. Training advanced AI models requires significant electricity. Large data centers consume vast amounts of power every hour of every day. Countries expanding AI infrastructure must also think carefully about renewable energy, electrical grid reliability, and long-term sustainability. India continues expanding solar and renewable generation while increasing overall electricity capacity. Japan has extensive experience in energy efficiency and industrial optimization. Finding ways to make AI infrastructure both powerful and sustainable may become one of the defining engineering challenges of the next decade. Financing is another piece that often receives less attention than it deserves. Building semiconductor facilities costs billions of dollars. Large AI data centers require major long-term investment. Governments can create incentives, but private companies ultimately play a central role. Stable partnerships help reduce uncertainty. Businesses are generally more willing to invest when they believe policy, infrastructure, and international cooperation will remain consistent over many years. That is why diplomatic relationships increasingly influence technological development. Technology no longer exists separately from international cooperation. The two are becoming deeply connected. Of course, it would be unrealistic to assume every proposed project will succeed. Semiconductor manufacturing remains one of the most difficult industries in the world. Artificial intelligence changes rapidly. Competition from the United States, Europe, South Korea, Taiwan, and China remains intense. Every country is investing heavily. Success is never guaranteed. Yet the significance of the India-Japan partnership does not depend on overtaking every competitor. Its importance lies in building complementary strengths. One country contributes large-scale software development, digital adoption, engineering talent, and a massive domestic market. The other contributes advanced industrial capability, manufacturing expertise, precision engineering, and decades of semiconductor experience. Instead of duplicating each other's strengths, they can reinforce them. This reflects a broader shift taking place across the global technology landscape. For years, countries often competed by trying to control every part of the technology chain themselves. Increasingly, governments recognize that resilient partnerships may offer greater long-term stability. Trusted supply chains, shared research, joint investments, talent exchanges, collaborative innovation. These ideas are becoming just as important as individual technological breakthroughs. Artificial intelligence has accelerated this trend because no single technology stands alone anymore. A language model depends on chips. Chips depend on specialized materials. Materials depend on manufacturing equipment. Equipment depends on engineering expertise. Data centers depend on electricity. Software depends on researchers. Researchers depend on universities. Every layer supports the next. Seen from this perspective, the growing cooperation between India and Japan is not simply about building better AI models. It is about constructing an ecosystem capable of supporting the next generation of digital industries. Whether that ecosystem ultimately becomes one of the world's leading AI partnerships will depend on many factors still unfolding today. Investment decisions, research breakthroughs, education, infrastructure, global markets, geopolitical stability. Each will influence the outcome. But one lesson is already becoming clear. The future of artificial intelligence will not be shaped only by the companies that write the smartest algorithms. It will also be shaped by the countries that understand something equally important, that AI begins long before the first line of code is written. It begins with the factories producing semiconductor materials, the engineers designing precision equipment, the workers building energy-efficient data centers, the researchers developing multilingual models, and the partnerships capable of connecting all those pieces into a single, resilient system. That may ultimately become the most valuable roadmap of all.